A car accelerates uniformly from rest to 20 meters per second over a distance of 30 meters. Given that the outer radius of the car's tires is 25 centimeters, what angular acceleration did the tires have? So, wouldn't it be neat if I were just asked for ordinary acceleration here, right? Because if I look at the numbers, the first couple numbers that are given to me there, the accelerates uniformly from rest part isn't really a number, but it implies an initial velocity equal to 0. And then since that 20 meters per second, I think pretty clearly I can interpret as a final velocity, and we're talking about a displacement of 30 meters. So in that sense, if I were to write the fourth kinematic formula, okay, and recognize that this part is 0 and solve for acceleration, then acceleration would be equal to that final velocity divided by 2 times the displacement, and all I'd have to do is 20 meters per second squared divided by 2 times 30 meters. And if I go into my calculator, it looks like I get like 6 2/3 or 6.66. Whoops. Let me just make it 6, 7. Actually, no, wait. Let's keep some more, right? Because we might use this. So, all right. I'm being a little slippery with my sig figs here again. Anyways, but there it is. That's the acceleration that I get. But I am asked for angular acceleration, and I'm also given the radius of the car's tires. So here's the argument I'd like to make, is that if the wheel, or the tire on that wheel, is rolling over the... Hang on, let me try to draw a better wheel. Maybe I should have drawn the wheel first and then the ground. That could have been easier. So, okay, we got a somewhat lumpy wheel there, but that's okay. My argument is that if this tire with a wheel has a linear acceleration a, that should also be the tangential acceleration at some point on the tire, provided that the tire is not slipping over the road. So I kind of have to make the assumption that the tire is not slipping in order for this to make sense. But I think that might be okay, since this is not necessarily... I mean, this is a pretty high acceleration, I guess, but it's not so crazy high. Like, if you think about like what coefficient of friction would be needed for the tires not to slip to achieve this level of acceleration, at a coefficient of friction of 1, you'd achieve free fall acceleration. This is less than that. It's maybe a little over 2/3 of that, since, 9.81 slightly shy of 10, right? Anyway, so it seems reasonable that the tires might not be slipping. And so with that assumption, if I can say that this really is the tangential acceleration, and then recognizing that tangential acceleration is equal to radius times angular acceleration, then the angular acceleration should be that tangential acceleration divided by the radius. So that means I'm going to take this number of 6.667, wherever you rounded it. Oops, I might have it in my calculator still a little bit less rounded. And then divide that by that 30 meters. And my calculator says that that is like 26.6666 repeating. Maybe at this juncture I could round that to 26.7. And what unit should I have here? I guess the meters cancel, right? And this makes sense, should be like a radians per second squared, but we write that as an s to the -2. So let's go ahead and check that answer